Massive cloud on collision course with the Milky Way, presented by Science at NASA. In 1963, an astronomy student named Gail Smith, working at an observatory in the Netherlands, discovered something odd. A massive cloud of gas orbiting the Milky Way galaxy. Smith's cloud contained enough gas to make 2 million stars, the size of our own sun, and it was moving through space at 700,000 miles per hour. For the next 40-plus years, the cloud remained a curiosity, one of a growing number of so-called high-velocity clouds circling the Milky Way. Interesting, but not sensational. Then something changed. In the mid-2000s, radio astronomer Jay Lockman and colleagues took a closer look at Smith's cloud using a Green Bank radio telescope in West Virginia, and they were able to calculate the cloud's orbit. Smith's cloud, it turns out, is on a collision course with the Milky Way. 30 million years from now, give or take a few million years, it will crash into the Perseus arm of our galaxy. The impact will compress clouds of gas in that spiral arm, causing a brilliant burst of star formation. There's no real danger to the Milky Way. Smith's cloud is minuscule compared to the gigantic spiral of stars that make up the backbone of our galaxy. But the coming collision has sharply increased interest in Smith's cloud. Andrew Fox of the Space Telescope Science Institute says, "We don't fully understand the Smith's cloud's origin. There are two leading theories. One is that it was blown out of the Milky Way, perhaps by a cluster of supernova explosions. The other is that the Smith cloud is an extragalactic object that has been captured by the Milky Way." To investigate these theories, Fox and colleagues recently peered into the cloud using the Hubble Space Telescope's Cosmic Origin Spectrograph. One of the elements they found was sulfur, absorbing ultraviolet light from the bright cores of 3 galaxies far beyond the cloud. By analyzing the amount of light Smith's cloud absorbs, the astronomers were able to measure the abundance of sulfur in the cloud. Fox says the abundance of sulfur in Smith's cloud is similar to the abundance of sulfur in the outer disk of our own Milky Way. This means we have a family relationship. He says the cloud appears to have been ejected from within the Milky Way and is now falling back. The cloud is fragmenting and evaporating as it plows through a halo of diffuse gas surrounding our galaxy. It's basically falling apart. This means that not all of the material in Smith's cloud will survive to form new stars. But if it does survive, or some part of it does, it should produce an impressive burst of star formation. While Fox's work has cleared up some of the mystery of the Smith cloud, many questions remain. What calamitous event could have catapulted it from the Milky Way's disk, and how did it remain intact? These are questions for future research. 30 million years to impact. The clock is ticking. For updates about the Smith cloud and other impactful science news, stay tuned to science.nasa.gov.
Hi everyone, this is Nibiru Watcher, watching the sunrise, and now this object is now at the 7 o'clock position. I'm going to catch it on time-lapse and regular video. Let's zoom in a little further on this. See it behind the trees, a lens flare over here. Let's zoom in on that. See, behind the trees. Oh my gosh, people. Let's get right with God. I will show wonders in the heavens and in the earth. Are there spots on this thing? I'm not sure. The time-lapse can't zoom in on it. Let's go back to time-lapse. Hi everyone, this is Nibiru Watcher, observing the second object. See the trees in the background. I've been catching this on time-lapse. See if I can see the trees blowing in the background. What is that object? Is it Nibiru or its moon? And that black object, maybe this, it couldn't be Nibiru, it's moving too fast around the sun. Or is it? Wow. Let's see that black object inside. It's almost the center of this second object. Let me zoom out a little bit. And I'm going to leave it just like that, actually. So let me move the camera out a little bit. You can see the lens flare there. But this, zoom out. See the lens flare. I'm going to stop talking about the stupid lens flare. Let's zoom in on this one object. 12 times optical zoom plus digital zoom. Appears to be moving closer to the sun and rotating definitely counterclockwise. We should be tracking it all throughout the day. So surprised that they're letting us see this with no chemtrails this time. Clearly you can see the pine needles in front of this object. If you say lens flare, well, I've already left my piece with that. See if I can zoom in just a hair better. I don't know if I can zoom in any better. I'll leave it alone. Let's put a welder's filter in front of it and see what it looks like. seem to, be too smooth of a round object to be a sun. It looked like Nemesis at first when it was low on the horizon, since it's been following up with the sun. It's almost as fast as the sun is moving. Actually, it must be moving faster. Zoom back out a little bit. You can see our lens flare again here. Notice how the lens flare is coming from this object, almost like in my other videos. I wonder what that looks like as the sun shines through this object onto the Earth. Can we go back to time-lapse mode?